In this video, we're going to take a look at systems of inequalities. So we're going to solve each system by graphing and shading in the feasible region. So what I want to do is bring up Desmos. So give me just a second. I'm going to bring up my Desmos and I'm going to clear out what I've got in there. Okay, so let's start with number 1. We have y is greater than the absolute value of x plus 5. Let's just type that one in first. So type it like it looks. Y is greater than the absolute value of x plus 5. Okay, so notice a few things about our graph. We have a dashed line because y is greater than but not equal to the absolute value of x plus 5. And then greater than means our shading is above that absolute value. So we need some points so that we can transfer this to our paper. So our vertex is always a good point to plot. I'm going to turn that into blue since I'm going to use a blue pen on my paper so they match. All right, so let's put the vertex is -5, 0. Then we just need some more points. So let's see. Does it let me bring up a table? No, I guess not. So let's pick out, let's see. Is that, looks like, we'll hit home so that my boxes are each worth 1. So when you hit the home button, your little boxes on the graph will all be worth 1 again. So it looks like -4, +1 is another good point. And -6, +1. And it's going to continue going up 1 box at a time. So like up 1 over 1. Our A value, in other words, was just equal to 1. Okay, then shade above that graph. So use your color pencils and shade with one color above that graph. Shade nice and neat, don't go below the graph. And make those lines dash just like it looks in Desmos. Then we're going to type in the next graph. So y is less than or equal to 2. So something you can do with Desmos is click on that first graph you typed in, that little dot on the side, and you can turn it off temporarily. So just looking at the next one, we'll be able to plot that separately, and then we can turn the other one back on and look at them together. So I'm going to plot the second one in red. So it has a solid horizontal line at y equals 2. So draw a nice solid horizontal line at y equals 2. And then let's shade below the graph, below that line with red. So you'll notice when you shade like this, there's one little area of the graph where those two shaded areas come together. So we can turn, let's put done, let's turn that other one back on, and you can see our graph on our paper now looks just like the one in Desmos. But there's a feasible region, we call it, right there, that little area that looks like the shading has overlapped. That is your feasible region. So a solution to this pair of equations, or inequalities, I should say, is inside of that feasible region. That's where all of our solutions are held. So we need to test the point 0, 2. That means, is that point in that feasible region? That's what we're asking. So 0, 2 is right here, and that would be a no. It's not in that solution, not in the feasible region. All right, what about -1, 6? So -1, +6 is located right there. And that's still not in that feasible region. So neither one of those 2 points was included. If they had said -5, 1, so -5, 1 is located in that feasible region, we would have said yes. So that's an example of when we would be able to say yes. All right, let's look at number 2. So let's type this one in. Y is greater than the absolute value of x -1 -5. So I'm going to keep my pattern consistent. I'm going to draw that one in blue. So let's get our vertex is located at 1, -5. So 1, -5, and it looks like we've got a y-intercept at -4. We have an x-intercept at -4 and at 6. So they gave us lots of good points. And notice that's a dashed line on each side, so definitely keep that dashed. It means it's not equal to any point on that line itself. So if you're asked about points that fall on that line, you would say no, they're not included. They're only included if it's solid. All right, so shade, just like it looks on Desmos, shade above the graph. Okay, so we're done with the first one. Let's turn that one off and type in the second one. So don't delete it, just turn it off temporarily. So let's put y is less than or equal to negative absolute value of x plus 3 plus 5. All right, so it's a solid graph. Our vertex is at -3, 5. So right there. We have an x-intercept at 2 and at -8. And a y-intercept at 2. And it was solid, so draw a nice solid line to connect those points. And we're going to shade below the graph in red. So using those colored pencils you have, this comes in handy. Hold on, let me do a little better job. It's my practice with my coloring skills. Okay. Try to stay with underneath there. All right, so then you can see that you have your, so we can turn that one back on to Desmos and we see that it matches. We've got our feasible region over there where the two shaded areas overlap. We call that a feasible region. It's where all the solutions to your system are. So we have 4, -2. The question is that point in that feasible region? So 4, -2, I got to move my arrow because 4, -2 is actually located right there near where I drew my arrow through there. So 4, -2 is tricky, and it's the ones they really like to ask you about because it's right there on the border of that feasible region. But if you see how like the red line is solid and the blue line is dashed, so this is actually a no because they have to both be solid to include that point on the edge of the feasible region. So if we were to test another value like, let's say -2, 1, that one's definitely included. So we would say yes. But if they ask you about -4, 0, just as another example, that would be a no because it sits on that dashed line. And anything on the dashed border would be a no. Okay, let's look at another one. So number 3, we've got y is less than or equal to x minus 4 squared minus 5. So let's focus on getting that one graphed. So we have 2 x-intercepts and a vertex. Let's use those to plot our points. So we got 4, here let's look at one at a time. 4, -5 is our vertex. Okay, then let's see. We just want that x-intercept because you want ones that are on that quadratic, that parabola. So 1.764, maybe it's about right there. And then 6.2 is about right there, and it's solid. So just draw a nice parabola that looks solid. Then shade underneath it with blue. So take your time, enjoy coloring for a minute, and shade underneath the graph. It really helps to use some colors and not just use a pen or pencil, but use stuff to make this graph look nice and colorful so you can really see where the feasible region falls, because that is what's important. So let's turn off the first one and graph the second one. So we've got y is greater than or equal to negative absolute value of x plus 3 plus 5. Okay, so we have an absolute value graph again. We have a vertex at, I'm going to turn that into red like I normally do. So we have a vertex at negative 3, 5. X-intercept at negative 8, and another x-intercept at 2, 2, and then there's a y-intercept at 2 as well. And this one is also solid. So draw a nice solid V-shaped graph and then shade above that graph. So above that absolute value graph, all those points are included. All right, so our feasible region, so you can turn the first one back on again and see that your graph looks like the one in Desmos. And our feasible region is over here. It looks kind of purplish because that's where our blue and red come together to look kind of purple. And we're just testing 8, 0. So 8, 0, notice is over here. There's actually another little area of your feasible region because of the way this one is shaped. So there's another spot on that side. So at 8, 0, that is actually in that purple area of your graph. So that would be a yes. And I just want to point out that if they had asked you about a point on the edge of this feasible region, like right here where those two come together, that would be a yes this time because both of those graphs are solid lines. Like their boundary line, we call it, is solid. And since they're both solid, where they touch would be a yes. Where on number 2, where they touched was a no because one of them was dashed and the other was solid. Okay, let's do the last one. Number 4. So let's type in y is less than, notice we're just typing these like they look. You don't have to do anything fancy. Just type them like they look. All right, so I just want to turn that into blue, and I've got a parabola. So let's plot the vertex at negative 4, negative 6. Let's get some x-intercepts. So we'll just round those off to be about negative 6.4 and negative 1.5. All right, and then make a dashed parabola. So just draw as best you can a nice dashed parabola and then shade below that parabola. Yep, my shading's messing up. Let me fix it. All right, there we go. So we shade below that parabola, and then let's type in the second one. So I'm going to turn the first one off, type in the second one. So we have y is greater than or equal to the square root of x plus 3. Then scoot over and make sure you put minus 5, but that it's not underneath that square root sign. I'm going to turn it into a red graph. Okay, so this time we have a radical function, so we need to plot this little point where it's ending over here. Let's see, it looks like negative 3, negative 5 is the little corner of it. So let's plot negative 3, negative 5. Looks like right there. Then you can tell the shading stops at that line where x equals negative 3. We have another good point for the y-intercept. It's at negative 3.3. And so let's just sketch a little line going that way and some shading that definitely does not go past -3. Let me try to do that better. Let's see. Okay. So take your time, shade it in so you can see where the purple is. So blue and red make purple. There goes my shading again, messing up on me. So it's in here. Okay, so we've got our feasible region in this purple area. Feasible region means these are solutions because they are feasible. They make sense, in other words, if you were to plug them back into both of these equations. Okay, so that's what it looks like, and we've transferred it to our paper, and we just need to test the point 0, 11. So 0, 11, it's hard to look at our paper because it goes off of our paper. So 0, 11 would actually be, let's zoom in a little bit. It's a y-intercept at 11, but notice like it's barely outside of our feasible region. So that would actually be a no. I'm trying to zoom in a little more. So see like 0, 11. I can't get it to click on there, but you can just tell that it's right outside of that feasible region. Okay, so that's it for the examples for this part.